Hey, health students. Getting back to the last section of communicable disease. We're going to talk through lesson 4 here today, which talks about emerging diseases and pandemics, which, like we said before, I think this entire chapter proves to be fairly interesting for us during this time that we're living in right now. But a couple of pieces of terminology that maybe you weren't as familiar with, but have become really familiar with over the course of the last 2 months. So you'll get into a little bit of this, and some of this will make some sense to you as to why we're living the way we're living right now. So taking a look here, but today, infectious diseases have the potential to spread quickly throughout the world. And like I said, this information really that you're going to get in this one is kind of like no kidding. So you're getting to that, going back to conversations of what could potentially have happened back in 1917, 1918, when they talked about the Spanish flu. That killed a lot of people, obviously. It had a lot of impact as far as infection around the world, but obviously didn't spread as quickly as it did. The reason for the sickness to the extent and the deaths to the extent that it had with the Spanish flu is because of the lack of medical technology and lack of technology with medicine and advancements in medicine. We have a lot of that nowadays, but it's so easy to spread because of the travel around the world. That was one of the first things that our government did from the get-go was close down travel, but apparently we didn't close it down soon enough. So that travel obviously came from Eastern Asia, but it was coming from other parts of the world from there. We shut down travel from China back in February, and that wasn't the only place. Just because our travel got shut down from that particular country doesn't mean that they weren't flying to other countries and then to the United States. So it was finding its way over here because of how easy it is to travel around the world. So emerging infections, these diseases are becoming more dangerous and worldwide or widespread. Vaccines and modern technology have saved millions of lives. Like we said, the technology helps, but communicable diseases continue to be one of the top causes of deaths around the world. So health experts label some communicable diseases as emerging infections. Okay, and emerging infections basically just means that they're diseases that we've known of, but things tend to emerge and change throughout the course of time because there's always differences in DNA and how some of these things change over time. So emerging infections.
Emerging infection. Communicable diseases whose occurrence in humans has increased within the past 2 decades or threatens to increase in the near future.
So that's one of the things that we've always talked about, that if, over the course of time, we've had World War I, we've had World War II, and everybody tends to think that World War III is going to be some kind of biological weapon. So there are emerging infections out there. Scientists now believe that some diseases, once thought to be non-communicable, may in fact be caused by infectious pathogens. Some of these diseases include Alzheimer's, diabetes, and coronary artery disease. So they're saying some of these things, these were non-communicable. They weren't contracted from one person to the next. And somebody's starting to think that there might be certain infections that have been passed from person to person that can ignite some of these, so to speak, non-communicable diseases like Alzheimer's, diabetes, and coronary artery disease. It's believed it's not 100%. One of those things that say, that's how they get them, but these are just theories that scientists have talked about over time. Factors that can contribute to the spread of emerging infections: transport across borders, population movement, resistance to antibiotics, changes in food technology, and agents of bioterrorism. So all things that we just basically talked about. We talked about resistance to antibiotics a couple of lessons ago. We talked about changes in food technology and how foodborne illnesses are there. And just now talked about agents of bioterrorism and how people will utilize biological weapons as a matter of of military defense from other countries. Just a couple of different emerging diseases that over time, the avian influenza is passed to humans if there's direct contact with infected birds or contaminated surfaces. Because no vaccinations or cures exist, and because humans have little or no resistance to the virus, health officials have watched these diseases closely. So these are different types of bird flu that are out there. West Nile mosquitoes sometimes feed on birds carrying West Nile virus. When infected mosquito bites a human, can transmit that virus. The best preventative measure is to protect yourself from mosquito bites. Salmonella or E. coli. Salmonella and E. coli are bacteria that are sometimes found in animal intestinal tracts. If people come in contact with bacteria by eating contaminated food produced by these animals, they may become ill. Recreational water illness, and this is another thing we talk about when it comes to going to different parts of the world. Say, for instance, I don't want to pick on Mexico, but for instance, if you go to Mexico on vacation, sometimes that water can be contaminated.
Giardia, a microorganism that infects the digestive system.
Okay, other emerging infections that pose serious health concerns could include HIV or AIDS, which has become a global health threat. Lyme's disease, transmitted from humans through tick bites. Severe acute respiratory syndrome, or SARS, a viral illness, and that was one that was pretty bad quite a few years ago. Mad cow disease, which affects the brain functions of cattle. Okay, so in looking at a couple of words here that maybe have come up quite often here over the course of the last couple of months. Epidemic can be a local or global proportions.
Epidemic, an occurrence of a disease in which many people in the same place at the same time are affected.
So an epidemic would be talking about, well, we've got a local epidemic in Midwest with COVID-19. But because this is not just within Midwestern states or even within the United States, because it's global, another term is used. That's the word pandemic. So diseases can spread with amazing speed. And like we said before, countries throughout the world are connected through trade, through travel, making it easy for infectious diseases to travel faster and farther than ever before. So when an epidemic is of global proportions, it becomes what's called a pandemic.
Pandemic, a global outbreak of an infectious disease.
Okay, these diseases affect the world. Any infectious disease can cause a pandemic. Health agencies plan for pandemics and develop rapid response strategies to reduce the impact of pandemics. So that's everything that you've heard over the course of the last 2 months. Self-isolate, quarantine for 14 days if you've been in contact with an infected person or a sick person, social distancing. These are all terms that have over time been developed by epidemiologists when infectious disease has hit at epidemic proportions or pandemic proportions. So thinking of that, how this kind of gets to the point where we're at now, we're kind of sitting at, okay, we've been self-isolated for so long, we've been under a stay-at-home order, we've been social distancing, now we're wearing masks. How long do people have to do this? And the biggest question gets to be is at what point in time are we going to be in the clear? Medically speaking, lots of scientists are saying we're not going to be in the clear until 100% until there's a vaccine. But you have to think about whether or not that vaccine is going to be developed to cover COVID-19 in every form of its mutated DNA over the course of the next couple of decades. Look at how many times the flu has mutated to the point where, you get people will get the flu shot and they get as many different strands of the flu as they possibly can involved in that vaccination, but some people still get it. So yes, a vaccination is going to help. It'll probably reduce the effects of any level of COVID-19, but it's going to find its way to continue to mutate over time. So over time, if it continues to do that, we have to continue to make this particular vaccination better. And that's why it takes so long for this vaccination to get done, because they're trying to get ahead of the virus. So pathogens become drug resistant in 3-step process. Like I said, when you're talking about mutations of pathogens invade the body and cause illness. Antibiotics can attack the pathogens. In this case, we're talking about a virus with COVID-19, so antibiotics they're not going to help. Antiviral drugs might suppress it a little bit or slow it down. But if you're talking about a bacteria of some sort, an antibiotic can attack those pathogens. The pathogens survive, but even if it does, even if there are pathogens, let's say there's a bacteria in your body that's causing an infection, and you take an antibiotic to take care of that pathogen, it's going to take care of a certain amount of those pathogens, okay? But there's going to be some that survive. So those pathogens that survive reproduce, creating a new generation of drug-resistant pathogens. So the ones that actually survive are now going to be resistant to that, allowing, again, your immune system to do its job to try and take care of some of those things. So your immune system, again, is still going to remember how it fought that off. But that's how antibiotics, certain pathogens become resistant, because some of them survive, and they found a way to survive it. And then they reproduce, and that's how things mutate as far as changing to the point where it's not going to work anymore. Lots of information. I went through it rather quick. There's so much more to know when it comes to epidemiology, when it comes to communicable disease. We have some really, really great health professionals in our community right now that are doing just a phenomenal job of taking care of people that are sick with COVID-19. We have a phenomenal group of scientists and doctors that are working at the federal level right now with the CDC and the World Health Organization, and trying to get ahead of where we're at as far as the spread of this particular disease. But understand that this is the job of some people in the CDC. They go to school to be epidemiologists, and they work on how to control the spread of emerging infections and diseases. So you've heard a lot about Dr. Fauci, I'm sure. You've heard a lot about Dr. Grhs that are working alongside the COVID-19 task force, and they've done a lot as far as trying to protect our country from the spread of COVID-19, but understand that they can only protect so much, and at some point in time, we either have to have a vaccination that can give us some sort of immunity to it. It's probably not always going to give us immunity. It might give us a little bit of immunity, or at least stop or slow down the level of infection that people get, so they don't get as sick. Or people are going to have to get built up immunity to it by being infected with it and recovering from it. Otherwise, it's still going to be out there, and it might be out there for a long time. So keep in mind that this is a process that people continue to become educated on to try and move forward. So it's interesting that this is one of our last chapters. That we have 2 more chapters after this, but this is one of the last chapters that we have with this class, and it's kind of fitting in the world that we're living in right now.